Here we go. So give me a function f. It says, what are values of c that satisfy the conclusion of the mean value theorem? So you have to have a flashcard that you understand and memorize that refers to the mean value theorem. Okay, the theorem is really, really simple to understand if you think of a picture. It's much easier than if you try to write it out with words. So we have this formula. Using this formula, we could find a whole bunch of xy pairs. We could then draw a picture of the xy pairs on a graph. Not knowing exactly what that looks like, I just do my standard, kind of make up something, I don't know. Okay. They're telling us to focus on the interval 0 to 3. That means x equals 0 to x equals 3. So I don't really know where that is, so I'm just going to pretend this is x equals 0. And we'll pretend that right here is x equals 3. Questions? Just stay caught up in your notes. Okay. The mean value theorem says that as long as f is both continuous and differentiable. So f has to be continuous and f has to be differentiable. Make a note of that. Then you calculate the secant slope between these 2 points. So if we find that secant slope here, find out what this value is, secant slope. The mean value theorem guarantees that one of these tangent slopes will be the same. At least one of them. You could have more than one. So the mean value theorem says if you find this secant slope, you're guaranteed that one of these tangent slopes will match. Question. So to make sense of this problem, we want to find this secant slope. So we need these two y coordinates. We already mentioned today how to do that. We just use our formula. So we say f of x equals 0 is going to be 0 cubed. That one's easy. That's nice. So f of 0 is simply 0. So we have this y coordinate. We'll find that one. So f of 3. Oh, they were very kind there. Made the math easy. Also 0. Question? Please, David. So the mean value theorem is telling me that I have, for this function, between these 2 points, whatever the slope happens to be, one of these tangent slopes needs to be the same. So I wanted to find this slope. To find the slope, I have to take the change in the y-coordinate divided by the change in the x-coordinate. And I didn't know the y-coordinates. But this is the formula for finding the y-coordinates, so that's what I'm doing. 2 points. So the change in the y is 0. The y-coordinate doesn't change. The x-coordinate does change by 3, but 0 divided by 3 is just 0. So my picture is not accurate, which is common. I don't really worry about it. The slope is actually flat. So the secant slope is horizontal. So I'm trying to find the place on the curve where the tangent slope is also 0. That's what they're asking me to find. To find the value that satisfies the mean value theorem means find the spot where the tangent slope is the same as the secant slope. Question. I'm going a little bit fast because of time. So I take the derivative, f prime. just like we talked about earlier today. If this equation finds all the points on a curve, when I differentiate this equation, I get a new equation which can find every slope on a curve. Now I want to find out at what x will this slope equal 0. So I want this to equal 0. So I'm trying to find the value of x which makes this a true statement. What value of x will make this be 0? It's a quadratic, so you need a factor. So take out a 3x. I'm left with an x minus 2. So there are two values of x which will make this equal 0. X equals 0 and x equal 2. Okay, the mean value theorem is never satisfied at an end point. It's kind of a technicality. We'll worry about that later. But so that's why the correct answer is 2 only.
Wait, sorry, can you repeat that last?
Huh? So the mean value theorem will always specify some interval, but you cannot satisfy the theorem at the end points.
Oh, I see.
It has to be somewhere in between. So even though x equals 0 does have a slope of 0, doesn't count. Plus it has to be between, can't be at the end.
So really, even just looking at that, you can cross out all
everything but
Yeah.
Like obviously, you need to do.
Correct. The little technicality didn't really get in your way
Yeah.
because this is the only one that's going to work. Because you've got to have a 2. You just might be thinking, why didn't they have a 0? The reason they didn't include the 0 because it's on the end.
Wait, can you explain that again?
So the mean value theorem will always refer to some interval. And the theorem is saying that somewhere on the interval, there is a tangent slope whose value is the same as the secant slope. But due to a mathematical technicality, really, the theorem cannot be satisfied at the ends. So we're looking for a point somewhere in between. So 2 is between x equals 0 and x equals 3. So that works fine. X equals 0 is on the end. That we won't call that a point that would satisfy the theorem. Good job, you got it.